Okay, Langelihle, I'm about to share my screen. You will just let me know if you are able to see. So let's see. Can you see my screen, Langelihle?
Yes, I can see.
Okay, okay. Then it's fine. Yeah, I did notice that during the week you managed to get all those problems correct, which is a very good improvement, Langelihle. So what I would like for us to do now, it is to accelerate a bit more. Then we will do some more complicated problems. But trust me when I say you will understand everything that I'm going to explain. The questions themselves, they may be tricky, but it's part of the game, honorable member. Not that you may find them difficult. It's only that we'll be doing them for the first time, you and I, but depending on your progress, you might not necessarily struggle. So we did law 1 and law 2. So now I want us to have a look at law number 3. So just write down there and say law number 3. So it's two more laws that we're going to be looking at. So law number 3, this is what it says, Langelihle. So if you have a base, maybe let me use a letter B, which stands for a base, and then let's say we have a exponent m, we close, we've got exponent n. The law says this will be equals to very simple, Langelihle. Maybe let me ask you, do you know that the brackets functions the same as multiplication?
Yes, I know.
Yeah, so it simply means this exponent inside multiplies that exponent outside. Or you can even say the exponent outside multiplies the exponent inside. So that means we are going to be having a letter B. Wait, between M and N, which letter comes first? M comes first. So that means it becomes MN. That's how the law works, a language. So I am now going to give an example. So let's say we have 2 to the exponent of 3 close. Maybe let's say we have 2 there. So according to the law, Langelihle, you can see the base will remain as 2. The only thing that you are going to be focusing on, it is just to multiply the exponents. It's like the main aim is to remove those brackets. So that means now we end up having a 3 that is multiplying 2, which is equal to 2 to the exponent of 6. So check something, Langelihle. Sometimes you may be having 2, let's say, into x plus 1. This one, when you remove the brackets, you do that by that, that by that. So it becomes 2x plus 2. So the difference between this one and the one that we have done, it's because this one, it does not deal with the exponents, but that law number 3, it is the one that deals with the exponents. That's why we call them the laws of exponents. Did you understand up to this point, Langelihle?
Yes, I understand.
100%. So now, let's see. I'm just trying to check if I should introduce law number 4. Maybe let me introduce law number 4, Langelihle. Not that complicated. The reason why I'm introducing law number 4, it's because we are going to apply these two laws at the same time, meaning we might be given a question that requires us to apply the two laws. So let's see, law number 4, not complicated. It says, if we have A as a base that we are multiplying with B as a base, and then we say to the exponent of n, this is equals to, maybe let me keep it simple by adding x there and then add y there. So that means, Langelihle, this n will multiply that, it will also multiply that. Remember, it is the exponents that we are multiplying. So that means we end up having a to the exponent of nx multiplied by, then you do the same for the other base, which is base b, and then you are having n multiplying by y, and that is the end of it. Does it make sense, Langelihle?
Yes, it makes sense.
100%. So now, let's look at an example. Maybe I will say 2 to the exponent, let's say 3 multiplying, let's say 3 to the exponent of 2. And then I'm going to close there. Then I will say maybe 4. So if we have to apply this law, we will therefore say 2 to the exponent of 3 times 4, and then we have 3 to the exponent of 2 times 4, and then the answer becomes 2 to the exponent, what is that? Is it 16? No, 12. Multiplied by 3 to the exponent of 8. Then that is the end of it, Langelihle. Did it make sense? Have you got any questions on that one, Langelihle?
Yes, it makes sense.
No questions. Okay. Then it's fine. Going to insert a blank page there. Then we continue. So now let's see. What we are going to be doing, it is to do more of, I will start with examples, and then I'm going to give you some exercises to do. I'll just be randomly selecting some questions, and then this will be preparing you for your next homework. But in today's lesson, Langelihle, you're going to be doing more of writing, because I need to see what you're going to be thinking. I need to see your approach. I need to see your presentation, and that also includes your handwriting. So now let's see. The question will be saying, simplify the following. So the reason why we simplify, it's because it's not equation. So we've got the first example there where we are given, let's see, this is 2x to the exponent of 5, and this is multiplying. Inside the brackets we have negative 3x to the 3, y close, and then squared. very complicated problems that we're going to be doing in today's lesson, Langelihle. Just in case if you've got no idea, or in case if you were confused, please do not allow me to continue, honorable member. You mustn't allow me to continue because we need to make sure that everything makes sense. Okay, I'll attend. It might also transfer to the iPad. Wait, Langelihle, can you hear me?
Yes, I can hear you.
Okay, then it's fine. There's a call on my phone, is connected to the iPad. I'll just, okay. Then let's see. So what you need to do, Langelihle, every time when you are given a maths problem, you need to know where to start. Maybe let me also start this way and ask you to say, what type of a maths problem would you say this is, Langelihle? Is it an equation? Is it an expression? And what will be the reason?
It's an equation.
It's an equation, okay. What will be the reason?
I don't remember.
Okay, so let me do this. Let me do this. I'm just wondering, okay. No, then it's fine. I'll do it here and say the word equation. So just that part of equate, it should just remind you of equal sign. So that means when you have an equation, that's if you have an equal sign. And then this one of expression, that means that's if you do not have an equal sign. So that means equation will be a maths problem that has an equal sign, and then expression will be the one that does not have an equal sign. So let's try it again, Langelihle. What type of a maths problem is this? And what will you say it is the reason? Langelihle, are you still there?
Yes, I'm sorry. Yeah.
Yes. Did you get my question on that one?
Yes, got your question.
Okay, give it a try. Equation, expression, and what will be the reason?
Using an expression
Okay, reason
because it has no equal sign.
has no equal sign, 100%. So now, the next important part of the lesson is to discuss where are we going to start. Do you have an idea of where you are supposed to start?
Yes, I do. Yes, I do.
Okay. Without having to do it, where are you going to start, or what would you do?
You wanna start with the brackets?
Yes, 100%. So that means we are going to say 2x to the 5. This is multiplying. And then when it comes to that part of the brackets, you remember the laws that we discussed. Maybe let me do this and check. Which law do you think we are going to apply on this question?
Law 4.
Yes, it's going to be law 4. In applying law 4, you just need to be careful of something. Can you see the coefficient, that one? It is a number, but it's inside. No, it has a negative. Can you see that part, Langelihle?
Yes, I can see.
So when it has a negative, you are therefore going to put inside the brackets and say -3, then you multiply it by that. Its exponent, it is that invisible 1. So that's why I'm having that invisible 1 being multiplied by 2. We know it will just be 2. And then we have x to the exponent of 3 that we will multiply it by 2. And then we have y to the exponent of, remember it has invisible 1. If it's nothing, then it will be that 1 times 2. Now you continue just to simplify those exponents, meaning you have 2x to the exponent of 5. This is multiplying. What is -3 squared? In brackets, -3 squared.
It's -9.
Okay, try to punch it on a calculator.
+9.
Yes, it's 9. So the reason why it's 9 is because squared means 2 of exactly the same thing. So that means you have -3 multiplying again -3. Negative times negative, it becomes positive. 3 times 3, it becomes 9. So that is the reason why it gives you +9 and not -9. Makes sense? Langelihle.
It makes sense.
So that means you've got 9, and then you will be having your x to the exponent that times that, which is, it's going to be 6. And then you've got your y to the exponent that times that, which is 2. So now we will therefore need to group them together because we no longer have the bracket. So by grouping them together, I mean the number multiplying the number. So that means we have 2 multiplying 9. And then we have x and x there. Then we can say we have x to the 5 multiplying another same base to the 6. And then what else do we have? We have y squared. So can you see? I'm also following the alphabetical order by starting with the numbers. In terms of the letters, it is x that comes first. Then 2 times 9 is 18. And then you see there, we apply those laws that we did. The law 1, which says when multiplying the same basis, you add the exponent. So that means the base is x. So you have 5 that you plus it with 6. And then you have y to the 2. So now you have 18x to the exponent 11 multiplying y to the exponent of 2. And that is the end of it. Did you understand the Langelihle?
Yes, I understand.
Langelihle,
Yes, I
did you
understand.
understand? Okay, 100%. So now, let's quickly add the second example. This is example B. Let's see, there we have, inside the brackets, we have -2x. We also have y to the exponent 3, and then that is to the exponent 3, divided by, we have 4x y to the 4, and this is multiplying 2x squared, we have 5. No, y to the 5, yes. This is what we are given a Langelihle. So you look at that and you realize you've got an expression. Why? Because we don't have an equal sign. Then we're going to simplify. Where to start? We start where we see the brackets. So we are therefore going to apply a law number 4. Then it means because the 2, it is a negative, then we put it inside the brackets and we say a negative 2 to the exponent of 3. And then we have x, we have 1 there, which is multiplying the 3. And then we have the 3, which is multiplying that 3. Then the whole of this is being divided by that. Maybe we can just group the denominators there and say we have 4 that is multiplying 2, and then we come to the letters. We will say we have x to the 1 that is multiplying x to the 2, and then in terms of the y, we start with that one of 4 and then multiplying that one of the 5. Did you see what I've done there, Langelihle?
Yes, I can see.
Okay. So now let's see. What will be negative 2 to the 3?
It will be negative 8.
Negative 8. Okay. Then we have, you punched it on a calculator, no?
Yes.
Okay. And then we are going to have x to the 1 times 3, which is 3. And then we have y to the 3 times 3, which is 9. And then the whole of this is being divided by, obviously, 4 times 2, that is 8. And then we have the same basis. What we do, we add the exponent. So we end up having x to the 1 plus 2, which is 3. And then what else do we have? We have y to the 4 plus 5, which is 9. So now you can see something here. We have a negative 8 divided by 8, which is negative 1. And then you can see you have that x to the exponent 3, then you minus by 3. Remember that other law, I think it's law 2. And then we have y to the exponent of 9 minus 9. And then you have negative 1 multiplying, this is 0. So it's like we have x to the 0. And then again, we have y to the 0. So it looks like we have negative 1 multiplying 1, which ends up being negative 1. Did I lose you there, Langelihle?
No, I understand.
Okay, then it's fine. Let's do some more examples. Which one are we going to do? Okay, let's do this example and say we have negative 4x squared. This is multiplying x. This is multiplying inside the brackets is negative 5 and square divided by, inside the brackets we have negative 2x to the 3, we close, we say squared. And then this is equals to, let's see, we will definitely need to work out our bracket. So everything else, we can just write it as it is. We just focus on where we have the brackets. Okay, let's say that. And then we have x. So what will be -5 to the 2?
It will be
Langelihle,
25.
yes, +25. That means we have +25 there. And then that one at the bottom, because it's a negative, we'll just put it inside the brackets and the outside exponent is squared. Then we have x3, that is multiplying that. And then let's see. So now can you see, we can try to group them, that number multiplying that one. So it's like we have -4, which is multiplying 25, and then we have x to the exponent of, you see now the bases are the same. What do you do when the bases are the same? You add their exponents. So it's like you have 2 that you added with a 1 divided by, what will be -2 to the 2?
It will be. Wait, what was the question?
Hmm?
It will be 4.
Yes, it will be a 4. And then we have that x. We have that x, and then the exponent is 3 that is multiplying by that, which is that. So now, what will be -4 times 25?
It will be 100.
Wait, what did you say?
It will be 100.
I can't hear you, Langley. Are you far from your phone?
No.
Okay, what will be the answer?
-100.
Yes, -100. I just wanted to make sure about the sign. So it's -100. Then we have x to the 3. And then this is over 4x to the 6. Looks like we can still work it out and say -100 divided by 4. What will that be?
It will be -25.
-25, 100%. So you have a -25 there. And then it looks like we can still say we have a x3 minus 6. Would you agree with me on that one, Langley?
Yes, I agree.
Yes, then we have -25 x to the -3. So if you remember, I said we always want to write our what is it? Our final answer as a positive exponent. Maybe let me rewrite this one there so that it will be clear. So that means we have -25x to the -3. So it's always best, you see, if it is not a fraction and our exponent is negative, then you just say -25, you write the coefficient as it is, then you say over, then you write it as +3. Maybe let me explain why. So it's like at this stage, you see, at that stage we have what is it? That divided by that, let's already say it's negative 25. Then you have x to the 3. X to the 3, it simply means 3 of the same thing over, and then remember these ones we have divided them, they gave us that negative 25. So 6 means 6 of the same thing. So that means we have 1, 2, 3, 4, 5, 6. So now you see that one cancels with that one. That one cancels with that one. That one cancels with that one. So it's like you have negative 25 at the top, everything cancelled, and then you remain with x, 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 which is negative 25 and x to the 3. Does it make sense there, Langelihle, regarding how to change it from there to there? I'm just trying to explain it in practice, where that comes from, or another way in which you can interpret it. Others would say, if you have the same basis, you always do them such that you say the bigger exponent minus the smaller exponent. For example, let's say we do have that negative 25, and then we will therefore say over x to the 6 is the one with the bigger exponent. Then you minus that one. So it's not like we always need to take the one at the bottom and then we minus it that side. So then it means you have that negative 25, which is dividing x to the 3. So you've got 3 ways in which you can approach it. Does it make sense there, Langelihle?
Yes, it makes sense.
100%. Okay, so now let's continue. Let's see. Okay, then I'm going to do the last example, and then from there I'm going to give you some problems to do. So now let's see. What if we have negative 2 into negative 3x, we close, you say squared, just multiplying x and y squared, multiplying negative 3 squared. Even though this negative, yeah, maybe a bit tricky, but let me not simplify it and leave it as it is. So now let's see a Langelihle. We are obviously going to start where we've got the brackets. So that means we have negative 2, and then here we have negative 3, square that, and then we have x. Obviously, it is invisible. 1 multiplying by 2 makes it 2. Times, we still have x, we still have y squared. You see, this one, Langelihle, in between, there is that dot, which means this thing is a negative and it's not a minus, because in between there's that dot, which means multiplication. You just need to be careful of that. So that means there's a difference between a minus and a negative. So now that means this one, this is that times then, is the same as you having negative 3 inside the brackets, and then you square that. That part, did it make sense, Langelihle?
Yes, it makes sense.
100%. So now, okay, we have negative 2. Obviously, this to the that we have seen many times, it gives us positive 9. And then can you see we already have the same basis? We're just going to add their exponents. So we'll see we have 2 that you plus it by 1. And then we have a y squared there. And then this one we've seen it gives us positive 9. So you will notice, Langelihle, for me, when I write math problems, if I've got a letter times a letter, I always put a dot. But if I have a number multiplying a letter, I put a dot in between. It's only when I multiply a number by a number, that's when I want to use that multiplication sign. The reason is because imagine if you have x that you must multiply by x. You see now, it looks like it's x, 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 but you actually want to say x multiplied by x. So that's why it makes it easier when you put a dot instead of x when you multiply the letters. Now imagine if you have 3 multiplying by x. Can you see? If you revisit this after 10 years, it may look like this is 3xx, whereas you wanted to write 3 times x, which is therefore the same as 3x. Does it make sense regarding the use of a dot and a multiplication Langelihle?
That could make sense.
100%. So now a -2 that you multiplied by 9, it gives us -18. And then this one, it definitely makes it x to the, no, it looks like we left out that 9, but it's fine. We'll check it on the next step. Then we have 3 there multiplied by a y to the that, multiplying a 9. So now we can just say that multiplied by that. So let's group them together and say that. No, because it's the numbers, I put a that, and then I'll say dot that, a dot that, and then it ends up being, what will that be, a Langelihle? What is that one?
It will be -162.
Wait, you said it's, what is it going to be?
-162 dot x to the power of 3.9 to the power of 2.
Yes, that and then that to the power of 2 there. Just hold on, I want to quickly. I want to quickly verify something, Langelihle. Let's see. Okay, let's be careful on something, Langelihle. I want to verify this because I'm suspecting I made it incorrect. So you see this part, that one, Langelihle, it was given to us as -3 to the 2. So that negative, it's not like it is included with that 3. So now let's try to prove something. This is what we're going to prove, Langelihle. We're going to say, what does it give us on the calculator when we say -3 squared? Does it give us 9 or does it give us -9? If it gives us -9, it therefore means this thing, if it's not inside the brackets, then we don't put it on our own inside the brackets. Do you understand what I'm trying to prove, Langelihle?
I understand.
Yeah, so on your calculator, maybe let me punch it on my side so that you will also see what I mean. There is that one there which is negative. So we'll say -3, then we say squared. Can you see what it gives us, Langelihle?
Yes, I can see.
Yes, it gives us -9. So that means I've done it incorrectly there. Now we need to correct it. So that means everywhere we were having 9, we put -that. I hope this one comes out. No. don't know why, but sometimes it does this, where it just cancels. I do not know why. Okay, then it's fine. I'll just add a blank page there, and then I'll quickly rewrite it. Wait, what's happening there? Okay, those are the laws. And I'll do that. So in case if you need this notes Langelihle, just be aware that this is recording, so they can be accessible. So very quickly, let me rewrite that, and then we redo it. So we have this, we have negative 3x, and then we have a squared there, we have x, y, and then we have dot in between, and then negative, and then 3. Okay, so this is negative 2 multiply negative 3 squared, and then we have x squared, and we have, this is 1 there, we have 2 there, and then this is negative, that gives us 9. So that means we have negative 2, that is multiplying, that is positive 9, and then here we have x, we add the exponents, and then we have that, we have negative 9, but dot in between because it's a negative. So that means we have negative 2 multiplying positive 9, and multiplying that negative 9, we have x to the 3, we have y squared. So this one we said, because of that negative and that negative, it makes it positive. This times that and that, it gives us that 162 x to the 3 and then y squared. And that will be the end of it, Langelihle. So one thing for sure, Langelihle, I can tell you now that if you can understand what we have done in today's lesson, not only to understand, but also be able to work them out, then we would have made huge progress, honorable member, because what we are doing in today's lesson, it introduces you to problems which requires application of multiple laws. You can already see that in some questions I've applied law 1, law 2, law 3, and law 4. So that is the goal, where you have a problem and you need to apply all the laws. Okay, so now let me see which problems I'm going to give you. Let's see. That, and that. And then I'll also give you let me not give you that one, but give you this one. Okay, I will give you, this is number 9, which is negative. This is b squared multiplying inside the brackets is a b to the 3, and then close, and then that. This is multiplying. I'm just writing as it is, Langelihle. Don't be surprised when I don't have a dot and I have multiplication. I only do it the dots when I start answering, because this is a question as it is given. That's why I'm writing it exactly as it is given without the dots, but multiplication. Are you ready to start working on it, Langelihle?
Yes, I'm ready.
Okay, then it's fine. So you will work on it as soon as you are done. You take a photo, then you send it to me via WhatsApp inbox. Nay. Did you hear me on that one, Langelihle?
Yes, I'm ready.
Okay, then it's fine. I'll just be waiting a long time.
Should I do this now?
Hmm.
Should I do this sum on the should I do sum now? This sum.
Wait, what did you say, Langelihle?
Should I do this sum
Oh,
on the
yes.
screen?
No, no. Yes. So you will work on this one. You write, you write, you write. As soon as you're done, you take a photo, then you send it to me via WhatsApp inbox. And then I'm going to check it. And then I will take it from there. Are you still working on it, Langelihle? Langelihle, are you still working on it? Langelihle, are you there? Okay, you are muted. You might be responding there, but be aware you are muted.
Oh, you're calling me? Oh, you're calling me?
Hmm? Yes, I wanted to confirm if you are still working on it.
Yes, I'm still working on it.
You're breaking the language. Are you still working on it?
Yes, I'm still working on it.
Okay. Okay.
Yeah, I'm done.
Okay, then you can take a photo, then send it to me via WhatsApp inbox.
Okay.
Okay, let me quickly check. So you have negative b to the that. Yes, that times that, yes. That. That.
I sent
That.
it.
Yes, no. I got it. And okay. I did suspect that all I've done you will understand, but there's going to be that tricky part. So let's redo it when you look at your working. So you obviously have negative b squared, which is now multiplying. Do you agree that we have invisible one there, Langelihle.
Yes, I agree.
Yeah, so which law is it? Which law are we going to apply?
I think law 4.
Yes, law 4. What does law 4 say? So law
I don't
4 says, you see that exponent outside, you multiply that and you also multiply that. Can you see there a Langelihle?
yes, I can see.
Yeah, so looking at what you did, can you see what you've done wrong?
Yes, I can see.
Yes, okay. Then it's fine. Very quickly rectify it and then resend again. So I think don't update it on that same one. So just start again and say 9. That thing is, it's not 8, but it's 9. So number 9, and then you redo it again. So you don't edit that one that you wrote.
Yeah, I'm done. I sent it to you.
Okay. Let me see. What? Yes. Okay. Let's see. Where's? Okay. Wait. Langelihle. Okay. Wait. The thing is, okay. This is that. That is two. That is six. That is six. Yes. And then we have 8, the 2, B. Okay, I want to know something, Langelihle. The thing is, it's blurry. It's blurry. I'm not able to see clearly there. You see that step number, okay, line number 3. Can you see that one, negative B, the one with negative b squared, line number 3, times a squared, is it squared, b to the 6 times negative b to the 6. Can you see that one, Langelihle?
Yes, I can see it on where I'm sending you now.
Let's see. Yeah, this one I can see. This one I can see. Okay, and let's see what happened there. It is a to the that, and then you have that negative. Okay, so you see between a squared and that negative b to the 12. Can you see that one, Langelihle? Second from last. Where you no longer have negative. You see that one, which is a squared negative b to the 12 times negative 6 to the, what is it? 6. Negative b to the 6. Can you see that one? This is the one that I'm talking about. A squared, you have that. I think this is that. Can you see this one, Langelihle? Langelihle, are you still there?
Yes, I'm still here.
Yes. No, don't mute yourself. It's fine. For today, you don't need to mute yourself. So what I wanted you to notice on that one is the fact that this, it looks like you have a squared minus b to the 12 times negative b to the that. So you need to then write it as a squared, in between have a dot, so that this dot, it's either you have a dot or times, so that we know that this is negative b squared. And then you can either have a dot or times, it doesn't really matter that much. You have negative b to the 6. Can you see this one, Langelihle? Then you can now either cancel those negatives, or you can say you have negative invisible 1, negative invisible 1. Then you rewrite it as a negative invisible 1 multiply negative invisible 1. And then you start having your a squared, and then you have your b to the 12, and then you have your b to the 6. Can you see what I'm doing there, Langelihle?
Yes, I can see.
Then you say that times that, it gives you positive 1, which you don't need to write. Then you end up saying have a squared. The question now is, if you have the same basis, what do you do to the exponents?
You add them.
Yes, so that means you're going to have b to the exponent, what, is 6, 7, 8. Then it becomes 8 in there. Can you see the mistake that you've done on that one?
Yes, I can see.
Yeah, so on these questions, Langelihle, we're going to make such mistakes where, for example, you get that one correct, you get that one correct, and then this part you get it correct, but just that part you then get it incorrect. So um, uh, the problems that I'm going to give you to do, when you make a mistake, when I say redo, it doesn't mean everything is wrong. You might find that correct, and then that part correct, but only this one wrong. So when I say redo, um, don't think there's somewhere maybe there where you could have made a mistake. It's because I want you to redo it until every section of it is correct. So just be aware that the mistakes that you might do is to confuse those laws. But this part of the lesson, we will have to do it over and over and over and over again until we master it, because this is what you need in order to have an understanding of mathematics, especially in terms of how you write, how you interpret, what happens when you multiply, what happens when you have the basis with the exponents and you have the brackets. So I'm going to give you another example, and then you will also give it a try and do just like we did. And let's see, which example am I going to give you now? Give it a nine. Okay, maybe let me give you this one. Let me give you this one, being number 8, which is 3 x squared y to the 0 multiplying. We have 3x to the 3 and then 0 there. Can you see that one, a Langelihle?
Yes, I can see.
Yeah, so that is the one that you can quickly do, and then as soon as you're done, take photos, you send to me via WhatsApp inbox, just like you did.
I'm done.
Okay.
Do you want me to send it to you?
Yes.
Yeah, I sent a picture to you.
Okay. Let's see. We have 3x squared. We have y to the power. Okay, fine. Okay, then it's fine. I'm therefore going to take you through so that you can see how this one it is done, because it has some interesting exponents there. So we always start where we have brackets. So we have 3x squared, we have y to the 0, and then we have, that means it's 3 to the 0, because it's like it's 1 times 0, which is 0. And then we have x to the, it's like we have 3 times 0 there. So we have 3x 2. What is letter to the exponent 0, Langelihle?
May you please repeat that question?
So what is a letter to the exponent 0?
It's nothing.
So in maths, nothing is 0. Then this one is not nothing, but it is 1. You remember when we said anything to the exponent 0 is 1?
Yes.
Yeah, so that means again, even this one is something to the power of 0, then we say it's 1. And then here we've got x to the exponent. What is 3 times 0? That is 0 most. So that means we have 3x to the that. 1 times 1 is just a 1. And again, even this one is going to be 1. So that means we just have 1 times 1 times 1. So it looks like we are having 1 there. So it's like you have 3 times a 1, which is 3, and then you have x squared. And that becomes the end of it. Can you see how you're supposed to work it out, language? Not an easy one. Not an easy one. It has its own trickiness, but did it make sense, language?
Yes, it made sense.
100%. So, any questions from your side before I sign out? Or
No,
did everything make sense?
everything made sense.
Yeah, so the questions that I'm going to give you, they are definitely tricky, language, very, very tricky. Not that they are tricky, just like you say, you understood everything. When you're going to be doing these questions that I'm going to give you, they're just going to be confusing questions. Not that there is something new, not that in their nature they are complicated. You'll just be applying all those different laws. The 4 laws, you're going to be applying those. So just take your time, come back to this lesson, try to watch it again, and then just take it part by part. Part by part, I mean, a first part, when it's been multiplied by another part, then you just concentrate on just that part that has the brackets. Then you apply the law that deals with when you have the brackets. Then from there, you try to group them together. You remember anything to the exponent of 0, it is 1. You remember, might be having negative inside the brackets. Then you remember how to work it out. And also when you have a negative, which is outside the bracket. Then we can leave it here, Langelihle. Everything's okay on your side, ne?
Yes, everything's fine.
Okay, until we meet again, honorable member, I will forward you the recording afterwards.